Okay, so I want to take some time to go through this worksheet, give you guys the right answers. So suppose you're dealing cards from a fixed deck. There are 30 red, 20 black, 10 green cards in this deck. So this is not your traditional deck of cards. You're dealing cards one at a time, recording the color, and placing it back in the deck and reshuffling the cards. So as soon as we see that you're placing it back in the deck and reshuffling, that means that one card is not going to affect the other, which tells me that these events are independent. Okay? So what that also tells me is that that whole idea of conditional probability will not apply in this problem at all, because one event occurring is not going to affect the probability of the next event occurring. If you deal a red card, record it, put it back in the deck, reshuffle that deck, and deal another card, you have the same probability of getting a red card as you did the first time. So this is just a straight multiplying problem. The first couple of problems are relatively simple. Find a probability of dealing a red card. Well, we look back, we know that there are 30 red cards out of 60 total cards, so it's 1/2. Find a probability of dealing a black card. We're talking about 20 out of 60, which is 1/3. Find the probability of dealing a green card. We're talking about 10 out of 60, which is 1/6. Okay. So now, find the probability of dealing 3 red cards in a row. Well, that means that the first card has to be red, and the second card has to be red, and the third card has to be red. You remember that AND means multiply. And the probability the first card is red is 1/2. And because these are independent, it's going to remain 1/2 all the way through. So it's really just 1/2 to the third power, which is 1/8, or 0.125. How about the probability of dealing 3 cards in a row that are not red? Well, in this case, I need to start by figuring out what's the probability of a single card not being red. Well, I could use the complement rule here, and I could say that's just 1 minus them being red, which is just 1 minus 1/2, which is 1/2 still. So the probability that a card is not red is 1/2. The probability that 3 straight cards, all not being red, would be, again, 1/2 to the third, which is still 1/8. Now we're looking for the probability of dealing a black card, a red card followed by a black card. A red card and then a black card. So again, it's multiplying. Probability of a card being red is 1/2. Probability of a card being black is 1/3. So 1/2 times 1/3 is 1/6. Specifically, I was asking red followed by black. In the next question, I'm not asking for red followed by black. I'm asking for red and black in no specific order. So it could be red followed by black, which we already know is 1/6, or it could be black followed by red. Well, black followed by red would be 1/3 times 1/2, also 1/6. So when I add those together, because this is or, it's 2/6 or 1/3 as a total probability. Okay, when dealing 5 cards, find the probability that at least one card is red. As we've said before, as soon as you see the term at least, we should be thinking complement. At least one card is red means 1 is red, or 2 is red, or 3 is red, or 4 is red, or 5 are red. So what would not fall into at least 1 is red? Well, the only thing that would not be a part of at least 1 is red would be no red. Well, that's relatively easy to find that probability. That would be 1/2 to the 5th, because there are still 5 cards. That gives me the probability of finding no red, 1/2 to the 5th. What do I then do with that probability? Since I want the complement of no red, I want everything else, I'm going to take 1 minus that 1/2 to the 5th power. Which is going to give me 0.9688 approximately. Again, no more than 5 cards are green. No more than 5 cards are green. Well, the complement of no more than 5 cards are green. I'm dealing 5 cards. Well, that would be no more than 5 would be 5 or 4 or 3 or 2 or 1 or 0.
Please report to the main office. Catherine Goldweiser to the main office, please.
Well, the complement of no more than 5 cards are green would be 6 or more cards are green. I'm dealing 5 cards. It's impossible for 6 or more cards to be green. The probability that 5 or less are green is 1. I found that just thinking about the situation. Therefore, the complement, the probability, this is my final answer. Since I'm asking you the probability that no more than 5 cards are green, it's impossible for more than 5 cards to be green. So the probability that more than 5 are green would equal 0, and then, as I established before, 1 minus 0 is 1. So the answer to this question is 100% likely that no more than 5 cards are green. It's kind of common sense. I kind of knew it at the beginning of the problem. Okay, if you wanted to use the complement there, you could by saying what's the probability that more than 5 are green, and that's impossible. Okay. The last question on this sheet: when dealing 5 cards, find the probability exactly 1 card is red. Well, that could be red, then not red, not red, not red, not red, which would be 1/2 for red times 1/2 to the 4th for all of those other cards that are not red. However, this is just taking into account the first card being red. Really, the second card could be the red card, or the third card could be the red card, or the fourth card could be the red card, or the fifth card could be the red card. So I have to add this together 5 times, or just take this total and multiply it by 5. So that would give me 1/2 to the 5th power times 5, which is 0.1563. And those are the answers to the worksheet.